All right. This formative, it was rough, but that's all right. We're going to be fine. We're going to go through it and we're going to talk about the thought process we want to have for each of these questions. So, doesn't matter 1 through 12. The first thing I want to be thinking to myself with each of these is this an additive or a multiplicative relationship? Because depending on which one of those relationships it is, I need to think about the different parts and what that means. So, looking at this first question, what is the slope of the line with the equation y equals 5x and y equals 1/2 x? So I need to think, is this an additive relationship where my equation is in the form y equals x plus or minus b? Or is this a multiplicative relationship where my equation is in the form y equals mx? These are both multiplicative. They both have a coefficient with the x. They both have a slope with the x. Again, this m, my coefficient is my slope. I need to know this to answer this question. It says, what is the slope of the line with the equation y equals 5x? My slope is my m, my number in front of the x. So for this first one, my slope is 5. My coefficient is my slope. My number in front of the x is my slope. For the second one, the slope, the number in front of my x is 1/2. And that's your answer for the first one. Again, we want to have this thought process. Is this additive or is it multiplicative for all these problems? Let's take a look at number 2. It says, use this table to answer the following questions. Is this multiplicative or is this additive? So I need to think, is this table adding the same number over and over and over again between my x and my y? Am I adding the same number over and over again? Or on my table, or am I multiplying the same number over and over again? So if I think about this, if it's multiplicative, 0 times what would equal 4? Nothing times 0 would give me 4. Everything times 0 would be 0. So I know right off the bat, this is not multiplicative. This needs to be additive. 0 plus what would give me 4? 0 plus 4 would give me 4. 2 plus 4 gives me 6. 4 plus 4 gives me 8. So this is additive because I keep adding the same number every time. So if I jump down to C, this middle or this third choice, x plus 4, shows me adding a number over and over and over again. So in our additive relationship, our B is our Y-intercept. Our B is our Y-intercept. Our Y-intercept is that number that we add over and over and over again. So in this problem, the number I keep adding over and over and over again is my positive 4. That's one way we've talked about it. We've also talked about whenever my x is 0, that y is my y-intercept. So we still get 4. You can think about it either one of those two ways, and we wanted you to explain that there. The y-intercept is the number we add over and over and over again. That's the b in our equation. Taking a look at number 3 again. First thing we want to think about, is this additive or multiplicative? A movie theater is offering a coupon for $3 off each regular ticket price. A lot of people told me that the word each meant multiply, so they thought it was multiplicative. But that each does not mean multiply. That each is not the key word here. When I have a coupon that's $3 off, that means that I'm subtracting 3. A coupon means that we subtract. So somewhere in my equation, I need to be subtracting 3. Our equations for these relationships are always going to be in the form y equals, and then I know that my x, whatever my movie theater ticket price is, I'm going to subtract 3 from it because I have a coupon for $3 off. Off is a key word. Subtraction. A lot of people didn't read this test. It says write an equation. That's all we needed. I just wanted an equation there. Number 4, I have to think. Is this additive or is this multiplicative? I know that this is multiplicative because I see the word slope. When I see the word slope, I know that that means I have to multiply. So right off the bat, for slope, it's a multiplicative relationship. That means on my graph, my line is going to go through my origin. Multiplicative relationships are proportional. I'm going to have a point at my origin. They tell me I also have a point at -6, -4. So -6 means I'm going to the left. Because it's negative, my x negative means I'm going to the left 6. And then I'm going to go down 4. So I go to the left 6. I go down 4. And here's a dot. So I've already got 2 dots. I need a couple extra ones. I need some additional points using my slope of 2/3. We know slope is rise over run. Slope is rise over run. So my slope here is 2/3. So that means from my point, I'm going to rise 1, 2, and then I'm going to run 1, 2, 3, and I have another point right here. I rise 1, 2, I run 1, 2, 3. There's my origin. I'm going to do one more point just to be safe. I'm going to rise 2 and run 1, 2, 3, and I have another point. To help you draw pretty perfect straight lines, you can click on this tool here. And what I can do is I can click through one, drag through my others to make it nice and pretty. And then I can click and drag through the others to make my line nice, neat, and pretty. Because I know sometimes it's hard to draw there. But again, the first thing I saw was slope. Slope told me this is proportional. I have to go through my origin. This one says graph the line that passes through -2, 3 and has a y-intercept of 5. So first off my point, -2, that means to the left 2, up 3. I have that point right there. Then it talks about a y-intercept. Is y-intercept part of additive relationships? Or is y-intercept part of multiplicative relationships? Y-intercept means this is additive. So on my graph, because this is additive, my line will not go through the origin. It does not go through the origin. It is non-proportional. This point right here is my B. Wherever my line crosses my y-axis is my B or my y-intercept. My B, my y-intercept are the same thing. for this problem, what does it tell me is my y-intercept? 5. So that means on my y-axis, my y-line, I need a point at 5. I need a point at 5. And again, this is additive. So I run 1, rise 1, run 1 for another point, rise 1, run 1 for another point. And then I connect my dots. The biggest thing is you've got to know the difference between a slope and a y-intercept. We've got to know slope is multiplicative. Y-intercept is additive. We have to know that quick. We have to know that quick. Number 6, write the equation of the line representing the relationship shown in the graph. So again, people not reading, not slowing down and reading your test. Write an equation. Write an equation right off the bat. It does not matter if it's additive. It starts out y equals. Multiplicative, it starts out y equals. If I need to write an equation, the first thing I need is y equals. And I have to think, is it additive or multiplicative? It doesn't go through the origin, so it's not multiplicative. It is additive. It does not go through the origin. We have a y-intercept. We have a b. So what would my b be in this situation? What is my y-intercept? What is my point on this y-axis? What number is that? That's -4. So that means my equation is going to be y equals x minus 4 because it's below the origin. It's at a -4, which is a -4. We did a pretty good job on this one. Is this additive or is this multiplicative? Is this additive or is this multiplicative? This is additive. So that means that Jenny is correct. It does not go through the origin. If it did go through the origin, it'd be multiplicative for Luis's answer. But it does not. It has a y-intercept. What number is that y-intercept? That's at 2. So if they wanted us to write an equation, this would be y equals x plus 2, which is what Jenny asked for, or what Jenny said. 8, matching cards. Matching cards. So just looking here, I have a table. On my table, I see I have the point 0, 0. If I have 0, 0, that means it's multiplicative. So it needs to be either 1/2 x or 3x. And I've got to think. I've got to think to myself, am I multiplying times 3 or am I multiplying times 1/2? Is 4 times 3 2? No. Is 2 times 3 1? No. So let's see if 1/2 works. 4 times 1/2, if I plug that in my calculator, 4 times 1/2 is 2. Oh, that works out. I'm just plugging in my x and multiplying my x times 1/2. 2 times 1/2 gives me 1. -2 times 1/2 gives me -1. So I know those two things are going to match up together. This one I see is an additive relationship. So I've got it narrowed down to y equals x minus 3 or y equals x plus 2. Is my y-intercept above or below my origin? It's below my origin. So that means I should be subtracting. So I match that with y equals x minus 3. So then I've got it narrowed down here. The bakery uses 3 cups of flour for each of their sheet cakes. Well, here's the number 3. And the keyword each also tells me that it's multiplication. This is the odd one out. Number 9, again, we have a word problem. We have to read to think, is this multiplicative or is this additive? Ashley washes several dogs each day. Several just means many. She is paid $25 to wash each dog. Is each additive or is each multiplicative? Each means multiply. So right off the bat, the first one is wrong. That one is wrong. That one is wrong. This is the only one that shows multiplication. Everything else is adding or subtracting. On this one, this was the ones where you could use the table, but you did not have to. It says graph the line that represents y equals 2x. So we stop and we think, is this multiplicative or is this additive? Multiplicative or additive? This is multiplicative. I have a slope. I have my slope, a coefficient in front of my x. So this is multiplicative. So right off the bat, I know I need a point at my origin. I know I have to have a point at my origin. Then again, I see my slope. My number in front of my x is 2. Slope is my rise over my run. Slope is my rise over my run. So if my number is 2, I need to make that a fraction. So I put 2 over 1. So I have a fraction for my slope. So I can rise 2, run 1, and put a dot. Rise 2, run 1, put a dot. Rise 2, run 1, and put a dot. And I connect them. Just putting a dot on the Y-intercept, I gave you points. Even if you didn't get the line correct or you got everything else wrong, if you had a point on the origin, that lets me know you know this is multiplicative. So that's one way to solve it. You could also, again, use this table and this equation to help you out. I take 2 times all my x's. So I would do 0 times 2, which is 0. So that means I have the point 0, 0. I take 1 times 2. 1 times 2 is 2. 2 times 2 gives me 4. 3 times 2 gives me 6. 4 times 2 gives me 8. And so then what I could do using the table instead, I can use these points that I came up with and plot them on here. So I have the point 0, 0. That means it goes through my origin. 1, 2. I slide 1, pop 2. I have another point. My x is 2, my y is 4. I slide 2, I come up 4. I have another point. I slide 3, come up 6. I have another point. Slide 4, go up 8. I have another point. And I make the exact same line here. Still going straight through all those points. Now they gave me the line, and again, we got to make sure we're reading carefully. It says, write the equation. You don't even have to know what the other words mean. You see, write the equation. And we've got to look and see, is this a multiplicative graph? Or is this an additive kind of graph? Additive, where we have a y-intercept, or multiplicative, where we have the origin? We have the origin. So that means this is multiplicative. Y equals, excuse me, y equals my slope times x. I have to calculate my slope. So if you zoom in on this table, I know I've got this point right here. And I see I have another pretty corner point there. My rise is 1, 2, 3. My rise is equal to 3. My run from my rise of 3, I run 1. I run 1. My rise was 3, my run was 1. 3 over 1, or 3 divided by 1, simplifies to just 3 for my slope. My m is 3. My m in my equation is 3. So y equals 3 times x. Y equals 3 times x. And then my last one, they give me the equation. I need to plot 2 points that lie on the line represented by that equation. So what that means is I need to put this graph, or that line, on here. So is this a multiplicative graph, or is this an additive graph? Even though it has a subtraction sign, remember, subtraction is part of the additive relationship. It just means that my b, my y-intercept, is going to be -2. Negative means it's above or below my origin. Negative means it's going to be below my origin. So my first point is going to be right there at -2. And then it's additive. So I rise 1, run 1, put a dot. Rise 1, run 1, put a dot. Rise 1, run 1, and put a dot. Rise 1, run 1, and put a dot. And then I need to make sure I connect my dots. I didn't take points off on the formative if you didn't connect your dots, but you need to make sure that you do. The line means it's an equation instead of you just putting dots on the graph. And so again, I can use my calculator to help me figure out what the y values would be. I do my x number and I subtract 2. So I do 0 minus 2, and I get -2. I do 1 minus 2, and I get -1. I do 2 minus 2, and I get 0. And if I take a look at my graph, I'll see that these points are on here still. I'm going to do these in red. So x is 0. My b is -2. That's right here. Oops, wrong thing, wrong tool. That 0, -2 point, that's right there. That's my b. My +1, -1, that's right there. That's the second line I did, the second dot. Slide 2, I don't rise or run any, I get 0. So those are the same points. So you can use this table to help you, but you do not have to. You do not have to if you don't want to. Again, if you have any questions, please, please, please let us know. Watch this video again to help you study. Let us know if you have any questions. Send us an email if it's after school. That's all right. Good luck on your summative next